Continuing on with exponents today, we're going to see what happens with zero and negative exponents. All right, so if you remember, when you divide, we really subtract the exponents. So for example, x to the fifth divided by x to the third would really get me x squared. All right, so let's look at something. Let's look at this little progression right here. 2 to the fifth is 32. 2 to the fourth is 16. 2 to the third is 8. 2 to the second is 4. 2 to the first is 2. 2 to the 0 is, well, what is 2 to the 0? Well, hopefully you see a lot of patterns going on here. The first obvious pattern would be the exponents. 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4. Right, they're going in order. It is base 2, meaning it's 2 is always being raised to some power. So let's see how the answers are progressing in a pattern. What did I do to 32 to get to 16? What did I do to 16 to get to 8? What did I do to 8 to get to 4? What did I do to 4 to get to 2? Hopefully by now you're seeing that really all I did was divide by 2 each and every time. So if we keep the pattern up, then we know this answer has got to be 1, because 2 divided by 2 is 1. Keep the pattern up. What's 2 to the negative 1? 1/2, because 1 divided by 2 is 1/2. 2 to the negative 2? 1/4. Right, I keep taking half of everything. So 2 to the negative third is 1/8, and 2 to the negative fourth is 1/16. Now, do you see any other pattern? Hopefully you see that if we look at, say, something like 2 to the fourth, which is 16, 2 to the negative fourth was simply 1/16. So a negative exponent ain't got anything to do with making the answer negative. It simply takes your number and reciprocates it. That means flips it upside down. We can do the same with any base. So let's say I took 3. 3 to the third. Well, 3 to the negative 3. Well, 3 to the third is 27. But you see that negative? It's going to make it 1/27. 3 to the negative 2. Well, 3 squared is 9. And the negative is going to make it into a fraction. 3 to the negative 1. Well, 3 to the first is 3. And then 1. And 3 to the 0, well, wait, it's going to be 1. So what did you see about anything that's raised to the 0 power? All right, anything raised to the 0 power is always 1, because when we do our pattern, in this case it's divide by 3, divide by 3, divide by 3, divide by 3, anything after the first power is going to be divided by its base, and it's always going to result in the number 1. All right, so let's look at a few examples. Oh, we're starting off with this one. Hey, this looks a little familiar. And this is what I want your brains to think. That's you. That's your brain. Feel free to put a hat on your head or do whatever. You should think 3 squared is 9. And then the negative is still in the exponent, which means to reciprocate and to make it 1/9. With this one, I got two orders of operation going on here. They want me to multiply and they want me to do a power. Well, according to our order of operations, PEMDAS, the first thing we're going to do is exponent. So the first thing we're going to do, I'll make this a little bigger so that you can see it, is we are going to take 2, and only 2 is being raised to the negative 4. So once again, you think 2 to the 4th is 16. I still have a negative, so that makes it 1 over 16. So now I'm left with that 4 still, because all we did was this, times 1 over 16. Well, hopefully you remember about cross-canceling. A numerator may cancel with the denominator, and my final answer here is 1/4. Wow, we got a lot going on in number 3. But once again, we are going to follow our good old-fashioned order of operations. So before we can do any division, we have to handle our exponents. So I'm going to start here in the numerator. 5 squared, and I have a power being raised to a power. Well, that was the other day's lesson. A power to a power means I multiply the exponents together. So that becomes 5 to the 6th. And I've got another power to a power going on in the denominator. So that becomes 5 to the 9th. Wow, I'm still not done because now they're asking me to divide. So once again, from the lesson the other day, you should remember that when we divide exponents, we subtract them. So that really becomes 5 to the negative 3. Wow, is this problem long? And now 5 to the negative 3, well, I think 5 to the 3rd is 125. But then that negative in the exponent means for me to reciprocate 125. All right, number 4's got a lot of juicy stuff going on. But again, we're going to go back to our PEMDAS and follow the rules of math. Parentheses. I got a parentheses, all right, but nothing that can happen in either parentheses. X squared, simply x squared, and down here 4 times x to the 7th times y, well, I can't clean anything up there. All right, so there was no parentheses. Exponents, see plenty of exponents. I'm going to start in the numerator. This is telling me to take x squared and raise it to the 4th power. Notice the 2 is not inside the parentheses. It is not getting raised to the 4th power. So when I clean up my numerator, poor old 2's got nobody to play with. X power to a power means I multiply. Down on the bottom here, however, the 4 is inside the parentheses. So the 4, the x to the 7th, and the y are all getting squared. 4 squared is 16. X to the 7th squared, okay, that means a power to a power, I multiply. Y to the 2nd is y squared. I got no multiplication I can do, but I do have division. So I look at each one separately. So in other words, even though I'm not going to, I usually don't write it, this is what my mind, scary place that it is, sees. The 2 and the 16, the x to the 8th, and the x to the 14th, and then the y squared doesn't have anybody on top, so we put a 1 to hold its place. Can I reduce? Absolutely. The 2 and the 16 reduce to a 1 and an 8. The x to the 8th and the x to the 14th, I see it as x to the 6th because there's more x's on the bottom and the y squared. So that's your answer. Now, some of you, if I pull, well, I can't separate it, so I'm going to rewrite it. Some of you may have said, well, couldn't you do this, Mrs. Trulin? Couldn't you have said 2 and 16 reduces to 1/8? And then I could have subtracted the exponents. 8 minus 14 would have gotten me x to the -6. And then, y squared would have gone on the bottom anyway? Yes, I could have. But you see this x to the -6? What do they tell me to do with negative exponents? Reciprocate them. So they change their spot. So I'm left with the 1 in the numerator, the 8 in the denominator. This x to the 6, since it was negative, must get reciprocated, and then the y squared. And we'll both get the same answers. Write each term with positive exponents only. Not sure what that means, but I'm going to start the problem and see what happens. Okay, this one right here. It's asking me to take -10 and raise it to the 0 power. Well, we just learned back on slide 1 that anything raised to the 0 power is always 1. Hey, that one wasn't that bad. So I guess this answer is 1. And what's the difference between number 5 and number 6? Well, if I erase that, there's a big difference. Number 6, there are no parentheses. So who's getting raised to the 0 power? Only the number 10 is getting raised to the 0 power. So 10 to the 0 power is 1, and then I still have this negative. So the answer here is -1. And this is a huge, huge problem that you need to understand. There is definitely a difference because of the parentheses. All right, x to the 10th divided by 2x to the -1. Well, there's 2 ways we can do this problem. Some of you will think of it this way. When I'm dividing, I subtract exponents. So x to the 10th minus a -1, cha-ching, will result in x to the 11th. So when I cleaned up these x's here, it was x to the 11th, whoops, and then this 2 stayed on the bottom. Sometimes I do that, sometimes I just do this. All right, now I took the time to write them in different colors so I can show you my thought process. If I look at this, the x to the 10th is perfectly fine to stay there. However, the x to the -1, I see that there's a negative exponent. So what do negative exponents tell me to do? Reciprocate. So that means that this x to the -1 has to flip, because that's what reciprocate means, and it comes to the top. And when it comes to the top, I've taken care of its negative, so the negative goes away. And there's still a 1 there. Now I can clean up. How many x's do I have in the numerator? 11. And that 2 is there on the bottom. So no matter which way you decide to do it, you'll get the same answer. Oh my goodness, it looks like a rainbow exploded. So this is how I look at it. The -64 and the 2, perfectly good old-fashioned math. That turns into a -32. X to the 4th, x to the 5th. I look at it as saying 4 on the top can cancel with 4 on the bottom, leaving me with 1x on the bottom. This a to the -2 can't be up the top. It's got to reciprocate because it had a negative exponent. So it comes down here to the bottom, and therefore, since I moved its spot, I took care of its negative. Everybody else is perfectly fine where they are. No other reducings to be done. So it's b to the fourth and a squared. All right, the last one. I've got a lot I can do in parentheses first, and then I've got an exponent. So I'm going to take care of what's in parentheses first. The negative 49 and the negative 7 can cancel. The u to the third and the u to the fourth can cancel. And the w to the fourth and the w to the seventh can cancel. All right, so I'm going to rewrite that. That's 7. A u to the third can cancel with 3 on the bottom, leaving me with a u on the bottom. And a w to the fourth and a w to the seventh can cancel, leaving me with a w to the 3 on the bottom. But now, everybody's getting raised to the negative 1. Well, remember, it just means everybody is going to get flipped. 7 getting raised to the negative 1 means the 7 goes down to the denominator. And all of this getting raised to the negative 1 means it's all coming up into the numerator. All right, so here's your summary. That's basically all we were trying to get you to learn today. Anything raised to the 0 power is 1, and a negative exponent commands you to take the reciprocal, not make the answer negative.